Hey everybody, it is Miss Lloyd coming at you with some transformations of functions. Yes, I said it that way, and you'll get over it. It's okay. So when we're doing some horizontal and vertical shifts, first off, we already talked about parent functions. All right, so vertical and horizontal shifts. So if we are adding something kind of outside of the function in addition to our parent function, so our parent function is this y is equal to f of x. So whatever function we're looking at, whether it's linear, absolute value, a quadratic, a cubic, doesn't matter. If we're adding something on the outside of that, it's going to shift things up and down. If we're adding or subtracting stuff on the inside, so with x, so you could see stuff like x plus 7 squared or cubed or to the fourth or whatever, so it's inside of those parentheses, then it's going to shift things either left or right. And inside the parentheses is a little bit opposite. So if it's adding, you're going to shift left. If it's subtracting, you're going to shift right. But if it's on the outside of those parentheses, then it's going to do kind of what it should. Plus goes up and minus goes down. So here we've got the parent function of f of x is equal to x cubed. They want us to sketch the graph of each of these functions. I'm going to do the one that's highlighted with my kiddos because I like them more than the people who I don't know who are watching this. I mean, I still like you guys, but let's be honest, I like people that I know more than people I don't like. If there's people in a burning building, I'm going to say the ones I know first because I'm an actual human person, and I'm going to stop talking now. So here I notice the only real difference with the original function and this new one is this plus 5 on the outside. Because it's on the outside, it's not inside the parentheses with that cube. This means it's going to be shifting up. So I'm going to take my parent function, and again, my kids and I have talked about parent functions before. These are the basic x values. When we plug those into x cubed, we get this stuff. And shifting up 8 means I'm adding, or sorry, 5. Shifting up 5 means I'm adding 5 to all of my y values. So I can show you the graph of what it originally was. So this would have been our parent function. And now we've just shifted everything up 5 units. I'm not really going to be able to fit everything on the graph, but that's totally okay. And so our red function is the new one. Just shifted up 5 units. We also have some instances where we have a negative involved, so a negative is multiplying in. So if we have a negative on the outside, we're basically multiplying all of our y values by this -1, and it's going to cause a reflection over the x-axis. So all of our positive y values are now going to become negative, and it flips from above the x-axis to below, or from below to above. Same thing happens if we have a negative inside with our x. We're going to multiply all of our x values by -1, and it's going to cause a reflection over the y-axis. So here we have the function f of x is equal to x to the 4th power. And they want us to write the equation for the function represented by the graph. So here, normally this is our parent function. So typically we would use -1, 0, and 1. If I use something that's like 2 or higher, it's going to be quite large. It's going to be in 16. And that's not something we can really graph. It's not going to be on the graph. So we would have +1, 0, and +1. So our original graph is going to kind of look like a parabola, but a bit flatter. So this is how the graph should normally look, approximately. And so we see that instead of pointing up, this is now pointing down. So it's reflected over the x-axis. So if it's reflected over the x-axis, that means that we should have had a negative out into the front. I can also see that instead of starting at 0, we're starting at 2. So it shifted down 2, which means we would have had a subtraction of 2 on the outside. So here's my new function showing all of the different things that have happened in order to get us from the parent function to the new red function. Our next bit, they want us to compare the graph of each function with the original. And so this isn't exactly the parent. We have this -1 on the inside. Because it's on the inside, I know it's affecting x. Because it's on the inside, I know it's going to be the opposite. So this is going to cause us to shift right 1. So basically, it's like I'm adding x to all of the x values of my parent function. When it comes to the square root, that's the parent function I'm looking at. I'm plugging in things that I know the square root of. and I'm just adding 1 to all of those x values. So then my new x is going to be 1, 2, and 5. So this is what we want to compare everything with. So the one that I'm going to do with you guys, the only thing that's different from this and the original function they gave us is this minus on the outside. So this is like I'm multiplying by 1 on the outside, which means I'm going to take that t-chart that we made before, and I'm going to be multiplying all my y values by -1. That's going to cause the reflection across the x-axis, since this is on the outside. Whatever happens on the outside is affecting our y value. So my new y's are going to be 0, -1, and -2. So that first point is going to remain the same. Now -1 instead of +1. Ooh, that point is not where it should be. That's 5. The other one was 6. There we go. And so this should be at -5. And we see it kind of looks like a sideways parabola, and we can see the reflection. It's like it's looking through a mirror, or the water, maybe like the reflection song in Mulan. The next one I'm going to say for my kiddos. We also have non-rigid transformations. So instead of things just shifting left and right, but maintaining the same shape, we could cause a stretch or a shrink. So just like I said before, if something's multiplying on the outside, it could be -1, it could be a 7, it doesn't really matter. We're basically going to multiply all of our y values by whatever's multiplying outside there. And then here, whatever's happening on the inside, we're going to be doing the opposite. So if I have a 2 multiplying with my x, that means I'm going to be dividing all of my x's by 2. So if it's a greater number, then we're going to be shrinking because we're dividing by that number. If it's a fraction, we're going to stretch because dividing by a fraction is the same as multiplying by its denominator, or its reciprocal. So here, our original parent function is just this x squared. So I'm going to graph that real quick. And so the one that I'm going to go over here online is I have a 2 multiplying in the front. So that means I'm going to be dividing all of, or no, it's multiplying on the outside. So we could have the square completely all on its own. There's nothing inside with the x. So that means because it's on the outside, I'm editing my y value. So I'm multiplying everything by 2. And so this is my new function. So I'm going to graph that. And there's our new function. So it's shrinking. It has shrunk. It did a shrink. It shrank. It did a shrink. Kind of narrowed. All right. So next bit, we're comparing these graphs. So it's like my original parent function, but instead I have this +3 on the outside. So because it's on the outside, that means I'm affecting my y value. I am working with a parabola, so I'm going to use my longer t-chart. And I'm shifting up 3. So because I'm shifting up 3, that means I'm adding 3 to all my y values. So this is what we're originally going to look at. This is what we're going to be making all of our comparisons on. And so here we have a 2 that's on the inside. So that means I'm going to be doing the opposite to my t-chart. So I've still got the -2, -1, 0, 1, and 2. I've got that new 7, 4, 3, 4, 7. Because we are doing it to this original. So when I plug this in, I should probably have done that first. That 2x is going inside with the square. So because that 2 is multiplying inside of the square with my x, that means I'm editing my x value, and we're always going to be doing the opposite. Instead of multiplying by 2, I'm dividing by 2. And my students kind of explored this before with GeoGebra. It's really nifty. You can kind of pick up your equations and see how it edits the equation as you move it around the coordinate plane. So now I'm going to graph this. So this one shrank. It got a lot more narrow. Again, the last one I'm going to share with my kids Hope you guys found this helpful. If you did, then please like, subscribe. And if you think that someone else could use it, please feel free to share. Spread that love.